probably the way you're going to prefer it. I'm going to show you both ways. I don't care which way you use, but most of you are going to find this what we call bookend method. We call this the bookend method, and solve for x. In other words, what we're going to be doing is we're creating a compound and inequality. So the way that this inequality works, we know that the standard period for our parent function goes from 0 to 2 pi. So mathematically what this is going to do, it's going to take care of two things for us. It'll take care of figuring out where the cycle is going to begin and end when we shift it left and right, as well as if you have a period change, what the units are going to be. So it's going to take care of period and the phase shifts if you have them both. So the thing you have to remember, there is a reason that b value is on the outside of the parentheses. Because without that b value being outside the parentheses, you do not know what the phase shift is. In other words, if you see your b value written like this number is not your phase shift. Only way you can identify your phase shift or how many units left or right you're going is if the number in front of x is a positive 1. So you may have to factor it out in order to identify the phase shift correctly. So for example, let's just take a look at cosine of 1/2 x minus pi. Pi is not your phase shift because the number in front of x is not equal to 1. So before you can correctly identify your phase shift, what you need to do is you need to factor out the 1/2. Now think about when you do your GCF factoring. When you factor something out, you're actually dividing it out of each term. Well, I know 1/2 divided by 1/2 is a 1. So now what I need to do is I need to take pi and divide it by 1/2. And what is pi divided by 1/2? Well, I know when I divide, I have to do what? Multiply by the reciprocal. So this is going to be a 2 pi. You can always check your answer after you factor out the b value, because when you redistribute, because that's basically what you're doing, is you're undoing the distributive property, you should get back to the original problem. 1/2 times x is a 1/2. 1/2 times 2 pi is a pi. So any questions on how I factored out that 1/2? Now, you can look at your expression. What is your phase shift going to be? Well, the minus is telling me to go in what direction? I'm going to go to the right. How many units to the right am I going to go? I'm going to go to the right 2 pi. The b value is still 1/2. That's that value you factored out. So you still find the period exactly the same way. I still have to take 2 pi and divide it by 1/2. That tells me the period. So what's the period of this function going to be? 4 pi. Okay? So any questions on that? So just remember, if that b value is not factored out, you have to factor it out to correctly identify the phase shift, which is same thing. We don't use that phrase shift left or shift right anymore. We use that phrase called phase shift when we're shifting these trig functions around. Let's take a look at number 2. Is pi over 3 going to be my phase shift or my horizontal shift? No. Because what do I have in front of x? I have a what? 2. So before I do anything, I have to factor out the 2. So I have 2 times x plus. Now when I take pi over 3 and divide it by 2, what is pi over 3 divided by 2? Pi over 6. So now you can now clearly identify what that phase shift is going to be. First of all, it's a plus, so what direction am I going? Left. And how many units to the left am I going? Pi over 6. B is still equal to 2. Again, that's the value that you factored out. B is always that number in front of x that you pull out. So to find your period, remember it's always going to be 2 pi divided by your b value. So what's your period of this function going to be? Pi. So any questions on how I identify the phase shift and the period? You guys go ahead and try number 3 for me. Yep. divide what by 2? Yeah, period's always 2 pi divided by the b value, because that's the standard period for sine and cosine's parent function. So for number 3, guys, what did you get inside the parentheses when you yank the 3 out? It's going to be pi over what? 12. So then what's your phase shift going to be, right or left? Left. Because again, you take pi over 4, you're going to divide it by 3, correct? Because you're always dividing by 3, correct? Now remember, how do you divide fractions? You're going to multiply by the reciprocal. Okay, so it's going to be left pi over 12. What's the period going to be here? The period's going to be what? 2 pi over 3. All right, so any questions on 3? Remember, you need to remember this in your mind. When you're dividing fractions, you're multiplying by reciprocals. Now look at number 4. Is there anything to factor out in number 4? It's already factored out, exactly. So what's your phase shift going to be? Your phase shift's going to be what? To the right pi. And what's your period going to be? Your period's going to be 2 pi divided by, what's that b value? 2. So your period's going to be what? Pi. So any questions on the rewriting that's going to need to be done when you have phase shifts? All right. So that's the last and final transformation. Just a quick review here. Again, we're now going to talk about all the different transformations. What does the negative sign in the front do? The negative sign is going to do what? Reflect. So that's your reflection over the x-axis, remember. The A is what we call the what? Amplitude. And remember, this tells you the number of units above and below the baseline. This tells you your max and min values, remember. Remember, B affects your period. Remember, it's going to be 2 pi divided by your B value. Just like from algebra, when you see that number added or subtracted to x, that's your horizontal shift, or what we call a phase shift. Remember, that's your shift to the left or right. We use a different vocabulary word called the phase shift. And just a reminder, remember, if you're going to the left, it's going to be a plus c. If it's to the right, it's going to be a minus c. And again, that plus d, remember, is your vertical shift. And again, that tells you where your baseline is going to be. So these are all the different transformations we've done. So like I said, we've done all of them except for that last one, phase shift. So really, the only new part we're going to be doing today is this step number 4. The rest we've already done. We're going to talk about this bookend method today. Because the trick is, when we want to label the x-axis, now that we're shifting things left and right, that first key point is not always going to be at 0. Where are we starting and where are we going to end the cycle, so we know how to label the x-axis? And that's what the bookend method is going to help us do. So let's take a look at number 6 first. And we'll come back and do number 5. So just like we've been doing, let's identify the transformations in number 6. What's the amplitude in number 6? 1. Do we have a reflection? No. What's the period going to be? The period's going to be 2 pi. Do we have a vertical shift? Down 2. And then what's your phase shift going to be? Are we going left or right? To the right, and how many units? Pi over 2. So there's really Two ways you can go about doing this, and I'm going to show you both ways on this example, and I'll show you the other ways as well. And what you're probably going to find is you're going to find that most of you probably prefer setting up the inequality. So the one way that we can do it when we set up this bookend method, the bookend method is nothing more than an inequality. We know the parent function has a period going from 0 to 2 pi. So what you do is you make a compound end inequality. It's always going to be 0. It's always going to be to 2 pi. That will never change because that's the parent function, period. What you put in the middle is your bx minus c part from the equation. So I take this x minus pi over 2, and I'm going to sandwich it in this inequality. If I had a b value, I would also include the b value there. What I'm trying to do mathematically is do the calculations to figure out where this new period is going to start and where it's going to end. Yes?
If you had it where you pulled out, I'm just making this up, let's just say you pulled out a 2, but and then it was the...
We're going to do one like that in number 5, if you want to hold off your question. We're going to do, I know where you're going with it, but you'd put the b value in there too. All right, are we good on this? So now remember, how do you solve compound inequalities going back to algebra? You want to get x by itself. So what are we going to add to all sides? We're going to add what? Pi over 2. So remember, you add pi over 2, the left, right, and the middle. So I have pi over 2 less than or equal to x less than or equal to. What is 2 pi plus pi over 2? 5 pi over 2. So now what you've just done is you have found right here this pi over 2 on the left. That's the starting point of this particular cycle. This 5 pi over 2 is the ending cycle. So, and it makes sense because you told me we're shifting to the right pi over 2. So if that first point was starting at 0 and I push everything to the right pi over 2, then that first point should be starting at pi over 2. So any questions on how I solve this inequality? So now what I'm simply going to do is I'm going to find the other key points. So I know I'm starting at pi over 2. I'm ending at 5 pi over 2. So you want to start by finding the midpoint. So just like what you had to do last night for homework, to find the midpoint, what do I do with the beginning and the end? I'm going to do what with them? I'm going to add them together. So pi over 2 plus 5 pi over 2. So what is pi over 2 plus 5 pi over 2? 6 pi over 2, which is just 3 pi, and then I'm going to divide by 2. So I know the midpoint's going to be 3 pi over 2. Yeah.
What if our period isn't 2 pi?
It always stays 0 to 2 pi. We're going to do one. The next example we're going to do is when the period changes. You always, because mathematically you're doing the calculations, we're seeing the change from the parent function. So we're going to do one like that with a period change next. So now what's the midpoint between pi over 2 and 3 pi over 2? So it's going to be pi over 2 plus 3 pi over 2, I know is 4 pi over 2, which is 2 pi. Divided by 2 is just going to give you pi. And then 3 pi over 2 plus 5 pi over 2 is 8 pi over 2, which is 4 pi. Divided by 2, that's going to give you 2 pi. So any questions, guys, on how I found the x-coordinates? So now I know how I'm going to label the x-axis. So again, remember, I'm no longer starting at the y-axis. I'm now going to start at pi over 2. So the divisions along my x-axis are that pi over 2 pi, 3 pi over 2, 2 pi, and 5 pi over 2. So some of you may find it helpful if you want to put a dashed line to help remind you where you're actually going to start, where you're going to put that first key point. Just like I've been doing a dashed line with a baseline, you may find it very helpful to do a dashed line where that first point's going to be. By the way, where is your baseline going to be? Your baseline is going to be down at negative 2. Your A value is 1, so I know my maximum is going to be up at negative 1. My minimum will be down at negative 3. Now, it's a cosine with no reflection. So where does that first point start? Max, base, or min? Max. So I know I'm going to go to the maximum. Then I'll go to the baseline, minimum, baseline, maximum. So there's your cosine with the phase shift. So getting your chart, it goes pi over 2, negative 1, pi, negative 2, negative 3, negative 2, negative 1. What's the domain of this function? All real numbers. Range is going to be what? Negative 3 to negative 1. Okay? So any questions on how we handle the phase shift? All right, let's go back and let's take a look at number 5. So now number 5, instead of having just a phase shift, you're going to have a period change. So now we know, what are we going to have to do with the 3? You're going to have to do what with it? Factor it out. So then I'm going to pull out that 3. That's going to give me 2 sine. And again, I pull out the 3, and that's going to give me x minus what inside the parentheses? That's going to be pi over 3. What's my amplitude of this function? My amplitude is going to be a what? 2. Do I have a reflection? No. What's the period going to be? The period's going to be 2 pi over 3. Do I have a vertical shift? No. But I do have a phase shift. Pi over 3, and I'm going to go pi over 3 to the left or right? Right. So any questions on identifying these transformations? Now, let's talk about doing the divisions. This is always going to be 0 to 2 pi, like I mentioned in the last example. Yes, I know the period is 2 pi over 3, but mathematically, what I put between the two inequality signs is mathematically going to take care of the phase shift and the period change. So now what I'm going to do, you can put either the original or the factored out form in between. It doesn't matter. So for example, I can put that 3x minus pi inside the inequality. Or you could put 0 less than the 3x minus pi over 3 less than 2 pi. It doesn't matter. You can get the same answer either way. Okay? It's just if you use the factor out version, what you'd want to do is you'd want to distribute the 3 first, which would get you back to the original anyway. So 0 less than 3x minus pi, I'm going to use my original. You can do less than or equal to, I'm sorry, it should be here. It doesn't really matter. What's going to be my first step to solve this inequality? Remember, when you solve equations, what do you do first before you multiply or divide? You have to do what? Add pi. So I'm going to add pi. So add pi to the middle, the left, and the right. So that's going to be pi less than or equal to 3x less than or equal to 3 pi. Then what? Then what to get x by itself? Divide by 3. So I end up with pi over 3 less than or equal to x less than or equal to pi. Remember what this tells you. It tells you that this cycle is going to start at pi over 3. It's going to end at pi. What did you tell me again the period was? You told me the period was what? 2 pi over 3. So this is where you can see what the period's going to be. I'm ending at pi. I started at pi over 3. So if I take pi and subtract pi over 3, that is a length of 2 pi over 3. So that's what I mean by that inequality takes care of doing all the period changes and the phase shift for you all in one. So any questions on where I got the pi over 3 less than or equal to x less than or equal to pi from? Yeah, go.
Well, I'm just wondering, don't we know the start point
Right, but we just don't know that ending point. Because you have the phase shift and the period change. So it just helps you get that ending point.
Is it just it's faster? Because like in theory you could do your little boxes and then like.
Yeah, I'm going to show you how you could also do that other way too with the transformations. All right, so now let's take a look at the x values. So again, I'm starting this particular cycle at pi over 3, and I'm ending at pi. So we have to find the midpoint. So what's going to be halfway between pi over 3 and pi? Well, I have to take pi over 3 and add pi. So what is pi over 3 plus pi? 4 pi over 3. When I divide by 2, I'm actually going to multiply by a half. So what's this middle point going to be? It's going to be 4 pi over 6, but when I reduce 4 pi over 6, that reduces to 2 pi over 3. So now I want to find the midpoint between pi over 3 and 2 pi over 3. So it's going to be pi over 2. And then the midpoint between 2 pi over 3 and pi. So we have to do 2 pi over 3 plus pi, which I know is actually 3 pi over 3. So that gives me 5 pi over 3. Divide by 2, which means I multiply by a half, so this other point is going to be 5 pi over 6. So now I label my x-axis. I have pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. Remember, I'm no longer starting on the y-axis. I'm starting at pi over 3. And I encourage you to do this highlight. I mentioned this when we were doing vertical shifts. Very common error students make is they constantly want to put that first point back on the y-axis. So this hopefully is a visual reminder that, you know what, I'm not starting on the y-axis. I'm starting at that x value of pi over 3. Where's your baseline? Your baseline is going to be where? 0. My amplitude is what? 2. So I know it's going to be 2 units above, 2 units below the baseline. Now it's a sine curve with no reflection. So where does this first key point start? This first key point starts where? Base. So it's going to be 0. Then I'm going to go to the maximum. So at pi over 2, I'll go to 2. Then I go back to the baseline at 2 pi over 3, which is 0. Minimum at 5 pi over 6 is negative 2. And then finally I end up at the baseline. So there's that sine curve with the phase shift. What's the domain of this function? The domain is what? All real numbers. The range is what? Negative 2 to 2. So hopefully you guys came up with these transformations to get started. Again, when you factored out your 2, you should end up with an x plus pi over 8 inside the parentheses. All right, and then you end up with that phase shift pi over 8 to the left. So any questions on identifying any of your transformations? Yes, Jorge. Remember, it's always 2 pi divided by this b value. You just got to remember, it's always 2 pi divided by that b value. Okay? Any other questions on that? So now we're going to set up the inequality, because in order to label my x-axis, I have to know where I'm going to start and where I'm going to end. Again, you can use the original or the one where the 2 is factored out. So I'm just going to use my original. And remember, it's always from 0 to 2 pi. That does not change, because that's your period of the parent function. What's going to be your first step to get x by itself? What's the first step to solve this inequality? Minus pi over 4. So negative pi over 4 less than or equal to 2x less than or equal to. What is 2 pi minus pi over 4? 7 pi over 4. And then to get x by itself, what am I going to have to do? Divide by 2. And again, remind me again, when I divide by 2, it's the same thing as multiplying by what? 1/2. So negative pi over 8 less than or equal to x less than or equal to 7 pi over 8. again, you should have a negative x value. Remember, you told me that you were shifting to the left of 0. So I know that the x coordinates to the left of 0 are going to be negative. So remember what this tells you. This tells you where your cycle is going to start and where it's going to end. And again, if you take the end and subtract the beginning, that would give you that period of pi. So when I go to do my x coordinates, yep, question? Where'd I get the what? The one, dividing by 2 is the same as multiplying by a half, remember? When you divide by 2, it's the same as multiplying by its reciprocal. So now I can figure out my divisions along the x-axis. So I'm going to start at negative pi over 8, and I'm going to end at 7 pi over 8. So now the question is, what's the midpoint between negative pi over 8 and 7 pi over 8? So if I add negative pi over 8 plus 7 pi over 8, what is negative 7 pi over 8 plus 8 pi, or what is 7 pi over 8 minus 8 pi over 8? That's going to give me 6 pi over 8, which I know is just 3 pi over 4. Divide by 2 or multiply by a half, that gives me 3 pi over 8. So any questions where we got 3 pi over 8 from? So then to find the midpoint between negative pi over 8 and 3 pi over 8. Well, if I add negative pi over 8 plus 3 pi over 8, that gives me 2 pi over 8, which is pi over 4. Divide by 2 is the same as multiplying by a half, so that's going to give me pi over 8. You guys go ahead and try and see if you can find this last point for me. The midpoint between 3 pi over 8 and 7 pi over 8.
Can you move the paper up so I can see?
What did you guys come up with for that last division? 5 pi over 8. Okay, so those should be the divisions along the x-axis. All right, so then if I label, I have negative pi over 8, pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8. Where's your baseline? Where's the baseline going to be? 1. So I know I'm going to start at the baseline of 1 and at negative pi over 8. I have an amplitude of 1, so my maximum's up at 2, my minimum's down at 0. Now I have a reflected sign. So where's that first key point going to be? Base, max, or min? Base. So negative pi over 8, 1. It's the sine curve. Remember, you just got to remember the pattern of your points. Sine always starts at the base. Because you have a vertical shift going up 1. So that's always your baseline. So after baseline, because I have a reflected sign, where am I going to go? Max or min? Min. So I know I'm going to go down to 0. And then at 3 pi over 8, remember I go back up to the baseline, which is going to put me at 1. 5 pi over 8 goes to the maximum of 2. And then 7 pi over 8, I go back to the baseline of 1. So that's what the sine curve looks like with that phase shift. All right, any questions on that? That pretty much has every single transformation you can possibly do for sine. If you can handle this sine curve, then you can handle probably any sine curve I give you. It's got everything in it. Period change, phase shift, vertical shift, reflection. The only thing that's missing is a different a value other than 1. All right, you guys go ahead and try number 8 for me. See if. So again, when I set up my inequalities to be 0, less than or equal to 1/2 x minus pi, less than or equal to 2 pi. What's your first step to solve this inequality? You're going to have to do what? What's the first step to get x by itself? We're going to add pi. So I have pi less than or equal to 1/2 x less than or equal to 3 pi. Then what? To get x by itself, I'm going to divide by 1/2, which is the same as multiplying by what? 2. So that's going to give me 2 pi less than or equal to x less than or equal to 6 pi. So these actually turn out to be nicer numbers than all the others we've done, because you don't have all those fractions. So any questions on where I got 2 pi to 6 pi? Again, remember, 2 pi is where you're going to start, 6 pi is where we're going to end. What's the amplitude in this particular problem? The amplitude is going to be what? 1. Do we have a reflection? No. What's my period going to be? Well, my period's going to be 2 pi divided by 1/2. So what's the period going to be? 4 pi. Do I have a vertical shift? What's my vertical shift going to be? Down 2. What's my phase shift? Left or right? Right. How many units? 2 pi. And my domain, of course, is going to be all real numbers. So now, again, when you figure out the divisions along the x-axis, these are going to be much nicer than the other ones, because there's no fractions to start. What's the midpoint between 2 pi and 6 pi? 4 pi. What's the midpoint between 2 pi and 4 pi? 3 pi. And then the midpoint between 4 and 6 is going to be 5 pi. So even though you had a fraction in the original equation, the divisions along the x-axis turn out to be a lot nicer. So again, I know I'm going to start this cycle at 2 pi. And I'm going to end it at 6 pi. Where's my baseline? Where's the baseline going to be? -2. So I know I'm going to start baseline at -2. My amplitude is 1, so my maximum's at -1. My minimum's at -3. It's a cosine with no reflection. So where's the first key point start with cosine? Max, base, or min? Max. So I know at 2 pi it's going to be -1. Then I go to the baseline at -2. Then I go to the minimum at -3, baseline, and then I go to the maximum at -1. So there's your cosine curve with the phase shift and period change. What's the range going to be? -3 to -1. Okay? So any questions on graphing with the phase shifts?